my name is Grace Witcher, and for my Physics Now project, I am answering the question of how infrared wavelengths in space help us see more of our universe. Our universe is one that holds many secrets that we discover every day as we continue to study it, and one of the greatest advances that we have made to help us understand our universe is using infrared wavelengths to help us study it. As we know, light waves are non-mechanical and therefore do not require a medium to travel through. So this is why we are able to see stars and very far off galaxies because space does not have a median. Therefore, light waves can travel through it. But since sound waves do require a median and are mechanical, this is why astronomers are only able to use light waves to help us study it. As shown on the diagram below, visible light has a much shorter wavelength than infrared light wavelength. This can cause visible light wavelengths to get blocked or absorbed by many particles in our universe, making us unable to see any visible light an object in our universe is producing. Therefore, when using infrared technology, infrared wavelengths are able to more easily slip past particles and to safely travel all the way to Earth for us to help us see and study. So this is why using infrared technology helps us see much more of our universe than just using visible light. How my topic covers some of the physics ideas that we have already learned is that light waves have different wavelengths, and this is explained earlier, showing how visible light has shorter wavelengths and gets blocked more easily, whereas infrared is on the opposite side of the electromagnetic spectrum and has much longer wavelengths and can more easily pass through particles in our universe. My topic also lightly goes over the topic of colors and their wavelengths and energy. Stuff that we know that red has the lowest energy and the longest wavelength, and on the opposite end, violet has the highest energy with the shortest wavelength. This is why when we see space images, we see more red, orange, and yellows than we do violet because red can more easily travel through space. This leads into the new physics idea that I have learned, and that is called cosmological redshift. This idea traces all the way back to the Big Bang Theory, and that how even to this day our universe is still constantly expanding, which is also expanding the wavelengths of light in our universe. Cosmological redshift states that as objects in our universe get farther and farther away, that the light that's traveling towards us is also getting stretched out to much longer wavelengths. So a wavelength that was once visible light now gets stretched out into a much bigger infrared wavelength, and it's also such as to why using infrared to study our universe has become more and more common. The diagram below is demonstrating just how cosmological redshift is working and also shows why it's called redshift. As we know, the color red has a much longer wavelength, so a once violet visible light wave coming from a faraway galaxy is getting stretched out into a longer red wavelength as it travels towards us. In my experiment, I wanted to test out how cosmological redshift works and if wavelengths will actually get stretched out as distance is increased. For my setup, I used 3 meter sticks and a slinky to try to replicate redshift. I started out by holding the slinky at 1 meter and observed how long the wavelength was, which was about 50 centimeters. I increased the distance of the slinky by half a meter every trial and did find in the end that the wavelength was increasing as I did so, and that at 2.5 meters, the wavelength was now 80 centimeters. In the picture shown, you can see that in the first and last image, just how the wavelength had increased as the distance was also increasing, which successfully showed that the distance and wavelength are directly related and helped to demonstrate how redshift is working in our universe. And you may be wondering, what is the importance of all of this? Well, I can tell you that this is important because this is how we are able to better understand our universe. Using infrared to help us see more of our universe helps astronomers to be able to better understand it and study it. Understanding how infrared is a more effective tool to us helps us to make technological advances to telescopes and satellites to better detect objects that we may once have not been able to see. Since infrared can pierce through particles and gas clouds in our galaxy, this helps us to be able to look past them to objects that might have been obstructed by said obscurities. Cosmological redshift is also very important because it is one of the ideas that comes from the Big Bang Theory, which is something that astronomers are still trying to figure out to this day. Cosmological redshift is an important tool for astronomers to use to understand objects that are trillions of miles away from us and just how far away they are based on their wavelengths. Since we know that in the case of redshift that distance and wavelength are directly related, it helps for astronomers to better guess how far away these galaxies are and how fast they are moving away from us. Altogether, infrared is a useful tool that helps us to see much of our galaxy and relates to cosmological redshift in the sense that much of our universe can be seen in infrared wavelengths and helps us to understand our ever-expanding universe. Thank you.